start from digital mockup. Okay, yesterday I finished till CAD, CAM. Okay, so yesterday I finished about CAD, CAM and all, right? What is CAD? What is CAD, CAM, right? The computer-aided design, computer-aided manufacturing. So what is conventional product design process, as well as the right now what they're using, that is product design and development cycle with computers. So all are replaced by the computers. First we will do virtually, then we will implement all the inputs, okay, to the real manufacturing system. Okay, this is what I explained in the previous class, right? Students, can you hear me? Hello.
Yes, sir, you're audible, sir.
Okay, so yesterday I finished all these things. So today we will go for so in this the main important is computer engineering. So I explained everything in the previous class. That is FEM. If you want to do static analysis, fatigue analysis, creep analysis, okay, everything, okay, you can do by using this computer engineering. Okay, so this is very important. Then we'll go for digital mockup. Okay, this is a simple technique, or this is a simple process, okay, which will be used, okay, for designing part. If you come for design of the product, okay, so this digital mockup indicates it is a concept. You can see here digital mockup, or it is called as DMU. Okay, if you go for industry, if anyone tells DMU, so DMU indicates digital mockup. Okay, so you should remember this. Digital mockup is nothing but DMU. Okay, it's a concept that allows the description of the product, usually in 3D, for its entire life cycle. Okay, digital mockup is enriched by all the activities that contributes to describing the product. So digital mockup is nothing but, okay, if you are finalizing the product design, okay, so it is a concept. It is concept of finalizing the, what I can say, the product design. Okay, once you finalize the product, so till the end of the life, okay, till the end of the life of the life cycle, okay, you should follow the same the same design, okay, for the product. So this is nothing but digital mockup. You can see definition. It is a concept that allows the description. So description is nothing but what are the specifications of the product. So what are the dimensions of the product? So with respect to that, what are the technologies you're adding to the product? Everything will come under the description of the product, usually in 3D. You 3D image in 3D, that is 3D the object, okay, 3D object for its entire life cycle. So this is nothing but DMU, that is digital mockup. So digital mockup is enriched by all the activities that contributes to the descripting the product. Okay, digital mockup is enriched by all activities that contribute the description of the product. The product design engineers, the manufacturing engineers, and the support engineers together to create and manage the DMU. So I told you, see, as a product design engineer, okay, if you finalize the design, okay, then all the department heads, okay, will come and they will analyze whether the design is okay or not. If they tell okay, then only, okay, your product design will go for manufacturing. So same is written. So the product design engineer as well as the manufacturing engineer, okay, as well as the support engineer, all will come come, and they will see the products. They will see the product design. If they're okay with respect to the design part, okay, then only it will go for manufacture. It will go for manufacturing the products. Because this is nothing but digital mockup. Digital mockup is nothing but once you finalize if you're finalizing the design of the product, everyone should look into the design. If they tell okay, then only, okay, it will go for manufacturing the product. Okay, so this is nothing but it's called as digital mockup. So what are the goals of digital mockup? You can see here: reduce the time to market by identifying potential issues earlier in the design process. So if you use this digital mockup, Okay, that is called concurrent engineering. I think you know concurrent engineering. Okay, you should follow that concurrent engineering here. So everyone should sit in this should come under the same process. They should follow up immediately. So once the product design engineer finish the design part, then immediately everyone should look into the process. Again, FEA team should come. FEA should do the analysis immediately, and they should follow up whether this design is okay or not, whether this design is sustained for that load, whether this design is good according to the customer requirements. Everything we should analyze, and and if it tell within a limited time, then immediately we can go for manufacture. Okay, if the design is really okay, if you're going for any new product development, okay, immediately, okay, if everyone says, if every what you can say, the managers, okay, the either manufacturing in the manufacturing department, or if you go for support engineers, or if you go for CEO, okay, if everyone tells okay regarding to the design part, then immediately we can go for manufacturing. Okay,
Sachin, do we have class? Where's sir?
Got disconnected.
Okay.
Students, can you hear me now? Hello?
Yes, sir, you're audible, sir. You were disconnected from 5 minutes back. Sir.
I think now we can hear you, right? Yeah, so hear me, right, Sachin?
Yes, sir, but we can't see your
Hello.
presentation, sir.
Okay. I will show you the present. Anyway, I will present the screen now. So I think digital mockup. So I was telling about the goals, right?
Yes, sir.
To right students, I was telling about goals. Okay. See, goals is first is nothing but reduce time to market to identify potential issues earlier in the design process. So we should reduce the time, right? So once you reduce the time to manufacture the products, okay, then you can supply the products early to the market, so that you can gain more profit, so the company can gain more profit. So that is the main what you can say theme of the company. So they'll be trying to gain more profit, right? More profit for the company. So like if you go for vaccine example, vaccine is the best what you can say right now, vaccine is the best what you can say
Example.
wait for 2 minutes. Okay, example is the your vaccine is the best because you see right now the India has around 139 crores people. So if you want to produce 139 crores vaccine, so how much days it will take? So only okay, if the demand of the product is more, so the company will manufacture the products within less time, so that we can supply to the market and we can gain more profit. So if you reduce the time, okay, while designing the products, okay, by taking the views from the product design engineer, as well as the manufacturing engineer, so support engineer, whatever it may be. So all the department heads, okay, will come and they will finalize the product design. So while product design, now, see, they will not as a product design engineer, okay, will not give only one design. So there'll be 100 designs will be there. So that 100 designs, they'll set the top 3 designs. Then okay, that 3 designs will go for the analysis. The as a FEA team, they will do the analysis. They will give the results. Okay, depending upon that results, then they will go for real. Then they'll go for prototype. A small prototype they will develop. They will do the testings. In the testing, okay, if it is okay, if the design is okay, then they will go for real life manufacturing. That is depending upon the demand, okay, which is there in the marketing, which is there in the market. They will manufacture the product and they will supply. So if you reduce the time, okay, while designing, then it will be good, okay, for the company, so that they can complete the process of manufacturing the real products, and they can supply it to the customers. So that is first one, reduce time to market by identifying potential issues earlier in the design process. Then reduce product development cost by minimizing the number of physical prototype that needed to be built. So you know this one. So if you do, so if all the department heads goes to the product design engineer and they finalize, okay, immediately if they finalize the design, okay, then you can say we can minimize the cost. See if you go directly to the prototype, if example, if other department heads will not go means they will not sit together with product design engineer, and if they not select, okay, if the product design engineer only is taking the decision and he will send the prototype, he will send the design, okay, to do the testings, okay, example I'm telling you. So if he sends, so in prototype, okay, if it fails, then the material which is used to do the prototype, then employees as well as the machines, as well as the cost of investment for the material, so all these are wasted. So that only right now, okay, the concurrent engineering is carried out. So concurrent means everyone will sit and they will finalize the product design, then it will go for FEA team, then they will do the analysis, they will tell the results, what is happening, okay, whether the material can sustain the load, whether the material is okay, whether the design is okay, everything they will decide and they will send. After that, okay, they will do the testings by doing a small prototype. Okay, if it is okay if the results are okay in the prototype, then it will go for the actual manufacturing, that is actual manufacturing of the products depending upon the demand of the product in the society. So this is second is very important. So we should not, what I can say, we should not increase the cost, okay, in the company. We should reduce the cost. How you can reduce the cost? By doing the virtual manufacturing system. By using the virtual manufacturing system, we can analyze everything, we can do FEA, we can see what's happening in the product, whether the design is okay or not, okay, whether we can do the optimization for the design, everything we can see in virtual manufacturing. Then we can go for developing a small prototype according to the results what we got in the virtual manufacturing. If the results are okay in the small prototype testings, then we will go for actual dimensions product, okay, we'll manufacture the product and we'll supply for the society. And last, we can see increase product quality by allowing a greater number of design alternatives to the investigation before a final one is chosen. I told you a number of times. So the product design engineer, for any problem, he will not do only one design. So there will be 100 types of a new design will be generated depending upon the other department heads. They will take the decision and they will tell, okay, this design is okay, this design is not good, okay, if you take this design, okay, we should invest more cost. So all these things, okay, will be analyzed by everyone, for all the department heads, and finally, okay, they will select one design, okay, which is best with respect to cost of investment, with respect to the raw materials which will be used, to the customers' requirements, okay, everything they will analyze and they'll fix, they will finalize any one design. So this is about DMU, that is digital mockup. So digital mockup indicates for 3D modeling, okay, you are 3D finalizing the design of the product, okay. So everyone got the information about DMU, right? If you have anything, you can ask me. So if you become product design engineer, you should know this DMU. So DMU indicates digital mockup. So digital mockup is nothing but finalizing the product design by taking the by giving the information for all the department heads, and they will tell you whether this design is okay or not, whether this design is okay. Send to the FEA team. We will send to the FEA team. They will do the analysis. They will send back they'll send the feedback later on. Okay, whether we can go for optimization of the design, whether the same design is okay. Then through everyone, getting the information through everyone, we will send any one prototype or one design for actual prototype. We'll do the prototype. We'll do the testings. In the testings, if we get the results are okay with respect to the virtual manufacturing results, then we will send for the real life, real manufacturing of real products. So anyone has any doubt in this DMU?
No doubts.
Okay, good. Others you should tell me. Next is model building. So what is model building? Can anyone tell me? What is the indication of model building?
So it's like kind of designing a prototype, sir.
Designing a prototype. Okay. Then
Like you get a general brief idea about like how your product will appear. Before manufacturing, you need to like at least show this and verify with the customer whether they are happy with the model or not. If they want any changes, then they can redesign or just make updates on it.
okay. Okay, good, Sachin. So model building is nothing but like if you take a car, okay, or if you take in anything. Here I have mentioned the 4 to 5 figures. So these are called as model building. So before going to actual manufacturing the product, we should show them for customers. We should show how it looks. Okay, like if you go for automobile industry like bikes or cars, whatever it may be, first we will create virtually. Then we will implement. We'll show everything for the other department heads. If they tell okay, then we will go for the customers. Okay, that is called stakeholders. Everyone with the employees or outside the customers. Okay, we will show the model how it looks. Then if they tell okay, then only we will go for implementation. Okay, so we should do FEA test also. If after doing FEA test, if everything is okay, then we will show for customers. If customers are satisfied, okay, then we'll go for implementing. That is, then we will go for manufacturing of the product. So this is nothing but model building. So if you go for the structure, okay, the construction of the buildings. So everything first initially we'll use the software to see how it looks, how the building looks. Then only if customers are satisfied with the 3D view with everything, then only we will go for actual manufacturing of the product or building or construction of the building. So this is called as model building. Okay. Then this slide is very important. Okay, this slide is very important. This is called as product structure modeling. Okay. So if you see an activity that is define product components, define product the assortment, product structuring, create master structure, documenting, and define product structure views. Anyway, okay, this product structure, create master structure. Okay, this I will do in the coming slides. Okay, later on at the end we will come to this slide. Okay, so that it will be better. You can understand in a better way, because this master structure I should explain you. Okay, then I should come here. I will explain this in the end. Okay, next we will come to the next slide. What is this model analysis? Can anyone tell me? Model analysis.
So you're testing it with respect to various criteria, sir. Like assume for stress, so you set the limit, you check the concentration at different region, and you see whether it is like meeting the parameters which are required for the product usage. And then you check with respect to even temperature, like how temperature will affect the material property. And you check whether this material should be selected or some other material should be taken for the same application.
Okay. See, model analysis, good Sachin. See, model analysis is nothing but finding the frequencies. I think in mechanical vibration, you saw the frequencies, right? The first frequency, second frequency, third frequency, right?
So mode of vibration, sir.
Yes, that is called model. That is called model vibrations. Model analysis is nothing but seeing the frequencies, finding the frequencies of the structure. Okay, if you take buildings, okay, the building can fail, okay, due to the first frequency or second frequency. That is when the external force is or external excitation is equal to the natural frequency, then your resonance come into picture, right? I told you this thing in the mechanical vibration. So your model analysis is nothing but finding the frequencies of the structure, okay, or doing the analysis. So once you do the analysis, okay, you can find the frequencies: first frequency, second frequency, third frequency, fourth, fifth, sixth. Always I told you the material will get failure due to the first 6 frequency. Okay, if the external excitation force, once the frequency is equal to the natural frequency, then the vibrations occurs. So once the to resonance that's vibration, huge vibrations occurs, then immediately the material will going to get failure. So this is nothing but model analysis. So model analysis is nothing but finding the natural frequencies as well as the excitation. See, first you find the natural frequencies of the system, then you apply the external force on the system, and you see whether the natural frequency is equal to the force frequency. If the both are equal, the first frequency, second frequency, third frequency, fourth and fifth, sixth, if anyone matches, that indicates the material or the structure is going to fail, okay, due to this force, okay, at the second frequency. I think everyone has understood, right? Anyone has any doubt in this?
No doubt, sir.
So I will explain you once again. So first you make the structure, okay. Then you find the natural frequencies of 1, 2, 3, 4, 5, 6. Still 6 frequency you find. Then apply the external force on the structure, or wherever you want. You apply external force or thermal, whatever it may be, thermal effects. You can apply the thermal, the temperature. Okay, you can supply the heat. You can supply the external forces. Okay, whatever it may be, and you see. Okay. Oh, so what are the frequencies? First frequency, second frequency, third frequency, and you match the natural frequency and this external force frequency. Okay, if first frequency is 60 hertz, if first frequency of the external force is 60 hertz, so that indicates the material is going to fail. Okay, once it reaches this force. Okay, once you apply this force like 50 Newton or 70 Newton, once it matches the external force, external frequency as well as the natural frequency, immediately there will be huge vibrations will be happening. There is huge displacement, okay, at that particular point, and finally the material will get fractured. Okay, wherever you get red, okay, so you can see here, okay, there's a red point. So this in this region, so there will be huge vibration will be happening. So finally the material will get fractured. So this is nothing but model analysis. Then you will go for product planning process. Okay, so can anyone tell what is this product planning process?
So is it like from the idea, like from conceptual design, how we are converting into 2D model, 3D model, and actual product?
Okay, good. So you can see the product planning cycle is a 5-stage process for gathering product ideas. Okay, developing product means product proposals, approving products for development, defining market requirements and functional specifications, and initializing development. So these are the 5 stages. I'll explain you one by one. So you can see the first inputs. What do you mean by input, students? So to develop a product.
So it's customer feedback or customer's opinions regarding a product, what they require in a particular product.
Okay, good. So product planning cycle is nothing but, okay, to develop a new product. So what is the process you should follow? Okay, that is called as product planning cycle. So you should plan according to the new development and new product development. Okay, first is input. So input is nothing but first you should take the customer's feedback about that product. Then sales. Then you should see what is the demand of the product. Okay, at that particular point. So what is the demand of the product you should see. Next, you can go for next, that is engineering. What's engineering? Can anyone tell me?
What process you need to do, or like what softwares are required to make a product?
Okay, good, Sachin. So what are the design tools are required? What are the softwares, that is analysis softwares or manufacturing softwares or design softwares? Okay, what are the requirement? What are the requirement you want for that product? So for the designing of the product. So that is engineering. Then tech support. You want to have the tech support to gather the information. Okay. Then market analysis. After that competitors. So you should know, these are called as inputs. You should gather all these informations first. So once you gather the information, then you can go for product idea defined. So this will be done by the product design engineer. So you can see a product A proposal, product B proposal, product C proposal. So this indicates, okay, so there will be 3 types of designs. Example, okay, if you want to manufacture a phone in your company, so what they will do, they will give a product proposal like 3 designs. So they will try to get the ideas. If they generate 100 ideas, I told you, right, all the department heads will sit and they will finally need 3, like product A, product B, and product C. Okay, that is called as product A design, product B design, and product C design. So these are the 3 designs what they finalize at the final stage. After that, product approval. So then it will go for approval, which design is good. So after once the designs of the product is okay, then it will go for testings. Okay, they will manufacture a small prototype and they will test. Once they do the testings, I think here product B is eliminated, right?
Yes, sir.
So because in testings, okay, because after the prototype, okay, once they do the testings, okay, it has failed. So that only product B is eliminated. So product A and product C is okay. So that is called approved project list. So once product A and product C is approved, that is product approved, then it will go for market requirements refined. Then we will see about the market requirements. So what are the requirements of the market regarding to that product? Okay, so according to that, we'll update the technology to the product. If you required, I'm telling you, if required, try to update any new technology to the product A and product C regarding to the market requirements, that is customer needs. Okay, then it will go for development initiated. Okay, then it will go
So
for.
one doubt, sir.
Okay, tell me, Sachin.
Sir, from the third to the fourth one, sir, like in this saying, product approved by A and C, but like market requirements are refined are A and B.
And I think it is C. It is not B. I think it's it is image, right? So that is C.
Yes,
That is C. Don't worry. It is not B. That is C, because project B is proposed only.
Based on the approval itself, you can choose the market requirement. Okay, sir.
So it is B. See, after I think here I told you, right. If you go for new product development, okay, immediately within 1 day or 2 days we cannot manufacture. So it will take long time, like 6 months or 8 months. But we don't know after 6 months a new technology may exist, right?
Yes, sir.
So that, see,
Like
after
my doubt was like assume, sir, in like product there were 3 products that were designed, and like only 2 actually went through like the approval, but that was approval based on the engineers. But what market required was A and B, so that's why they redefined it and they made based on that. So that's my doubt, sir.
no. Actually, this is, I think it is C. Market requirements defined. Okay, regarding to the I think B has been. See here, you can see product B proposal is been not carry forward in the product approval, right? So it has been eliminated. In approved list, you have product A and product C, and market requirements refined is nothing but is refining again A and B, right?
Yes, sir. That's what I'm thinking, sir. Like there were 3 ideas, but like engineers said only 2 is possible, but the market requirements, the first one and the third one. So based on that, they work on it and they prepare only like the first and second one.
I think see, market requirement refined. So depending upon okay, they want only A and B.
Yes,
See,
sir, that's what I'm trying to say, sir.
See, market required development. MRD indicates market requirements. Okay, so defined. So you can see here market requirement redefined. So that indicates whatever the customer needs, whatever the customer is asking. So we should redefine, right? Redefine those things. So, but you should analyze the Sachin, because see, right now I'm trying to make a new product development now, but okay, it will take around 6 months or 8 months. Before, I think 10 years back they were taking around 1 year or 2 years, maximum 2 years. But right now, okay, the company is telling to manufacture or to develop a new product within 6 months or 8 months. So after 8 months, we don't know what is the condition. So what is the customer needs? What are the new technologies that may exist in the market? So I think after 8 months, okay, they should be trying to update the technology, right, in the product. So I think according to you, A and B, okay, we should. So the customer is asking about product A and product B. So again according to the customer needs, okay, they are updating A and B product and they're finalizing, right?
Yes, sir. Because like if the customer is not even asking for product C, then it's no use of manufacturing it.
Yes. Okay. So then product C is waste. Product C, I think that product is wasted. Okay. Anyway, this ideas is different and the product is different. Okay. Anyway, product A and product B, okay, they're redefining once again according to the customer needs. After that, if all the tests are okay with respect to the product A and product B, they will test once again. Okay. If it is okay, then they will go for development, right? Development is initiated. They will go for according to the customer needs, they will manufacture the product and they will supply it to the customers. So this is product planning process. So these are the 5 stages in this product planning process. Okay, so this is regarding to the products. So that is asking regarding to the customers. Next, we will go for next slide. Okay, product structure. Can anyone tell me what is this product structure, then variant management and product the configuration? What do you mean by product configuration, students?
So product configuration means what are the specification of the product? Like assume a table. So what are the dimensions you require? What is the material you require? What is the strength you require? Like assume you need a table which can hold a weight up to like 340 lbs, such like that, sir.
Okay,
And
good.
then the product structure is like how it appears, like how is the 3D model? Like it has 4 legs, it has one place to hold the object, something like that. And variant management is just like producing the same product in different variants. Like you can see for car itself, you have hatchback, you have like racing cars. So it's just like based on the customer requirement, you're just making the same product with different design on outside, but it has the same what do you see the parts inside.
Okay, good, Sachin. Anyway, whatever you told, okay, that's correct. So this indicates variant configuration is nothing but example. If the chair, okay, you want in black, or if you want in brown, green, okay, so that is color. So this color indicates that variant configuration. Okay, example, I've written as office chair. So what type of color you want? What type of color, like black, brown, green, red? Okay, everything will come into picture. So this is about the variant configuration. And if you come for the product configuration, so that indicates whatever the Sachin has told. Okay, that is the how much weight it can sustain. Okay, then what is the length of the chair? What is the height of the chair? So everything, okay, is called as product configuration. So this indicates here, you can see the in the theory part, the general customer trend is that manufacturers are required to offer many variants of the same product, like the color I told you, gray, blue, red, green, everything I mentioned here. So this is called variant the configuration to meet the increasing diverse needs and desires of the customers. So one customer may ask, I want the black chair. One customer he can ask the green chair, example. So depending upon the customer needs, okay, we should manufacture according to the needs of the customer. Okay, then we can supply the products. Then we can see variant configuration supports collecting, advertising, ordering, and manufacturing complex products that are specifically tailored to customer needs. So always I am telling you customer needs. So that is very, very important. Regarding to the customer needs, okay, we should try to collect the information, and we should do the advertising, then ordering, as well as manufacturing. So all this will be done according to the customer needs. You can see here there is a lot of configuration I mentioned according to the seat cover. Okay, whether it should be leather or fabric. Okay, so what are the dimensions? Whether this chair is for a small kid or an adult, or you can go for 8 years or 70 years people, or middle-aged people. So all these things means comes under the variant configuration. Okay, so then this called as the product configuration and variant management or variant product. Okay, all this comes under this, the product structure. Then we'll go for material master data. What is material master data? Can anyone tell me?
So does it hold the entire data about like what are the material required for building a particular product? Like for assume for you can see for this one's a laptop. So you could require like steel, or you'll require like the inside part like electronic items. So based on that, you just store the data regarding each material which is required to manufacture this complete product.
Good, Sachin. So this is called as master material master data. So this regarding to the product, okay, everything will be stored here. So I told you, right, in the industry, if you go, okay, they will use first data collection, okay, or data store. Okay, they will use the Apache Hadoop or Apache Spark. I told you. Okay, but here we are not mentioning any software. Okay, in theory we will not mention any software, but I'm telling you, to store all this data in the MNC companies, okay, they will use the software. Okay, for storing the data, okay, they will use some software. For data collection, that is called as data storage. For cleaning the data, they will use some softwares. Okay, then for building the model, okay, they'll use some softwares. So for all this, okay, you want the software that is called as virtual manufacturing system. So material master data is nothing but storage. Okay, the storage of the information regarding to the product. So that is called as material master data. MMD indicates the storage of the data for the product. Okay, so you can see the theory part, the material master database often refers to the simple as the material master. Okay, comprising all the individual material master records stored in the system. System in the sense of computer, right? System in the sense of computer. So contains description of all the materials that an enterprise buys, then produces and keeps in stock. What is that keeps in stocks? Can anyone tell me?
So keeps in stock is like which is keeping in with him, like in his particular place, like location. Like assume, you can assume a jewelry store, sir. So they have a stock, like they store it inside. So when a customer wants, they can show even extra designs from inside, like an inventory.
Yes, okay, good. Keeps in stock is nothing but inventory. Uh, that is the extra material, okay, which will be manufactured in the company. So they will store there. Okay, if a customer needs regarding to the requirements, okay, they will bring and they will show the product. So this is material master database. They will store everything, every information regarding from the accounting, okay, to the information of the employees. All this will be stored, okay, in the master data. That is material master data. Then it is the central means it is a central means repository of information on materials such as inventory level for the enterprise. Description of the individual material used in an enterprise are stored in material master records. The following list shows some types of information a material master record contains and provides examples of each. So these are the information what I given, okay, in the in the material master data. So material master data is nothing but storage of what you can say the storage of data, okay, regarding to the material or regarding to the product. So example product, if you take a product, so what are the things you want to manufacture that product? Okay, that is called as storing the data. Next, accounting. First is accounting, okay, in that in that material master data. So valuation and costing or price calculation information. So everything we will store. Example, what is the price of the product? Okay, then past and future price. So past is nothing but before 2 years, what was my price of the product? Now what is the price? Then current valuation. So what is the current value of my product? So this is called as, in accounting, we will store all the information regarding to the price of your product. So what is the price now? What is the price before 2 years? And what will be the price after 2 years, after 2 or 3 years? So this is all the information we can store in that material master data. Then material planning and control. Information for material requirements planning, that is MRP. MRP indicates material requirement planning. Okay, how much material is required for manufacturing like 1,000 products? So how much materials or how much raw materials are required, okay, to manufacture that much products? And consumption based planning, inventory control. Okay, so all this thing, okay, we can store in the material planning and control. Example, you can see safety stock level, planned delivery time, and reorder level for a material. So these are examples what he has given. Okay, we can store these data, okay, in the system or in the software. So everything we can do in SAP. I told you SAP, right, in the previous class. So we can store the data in SAP, or we can store in the data in the Adobe, the Apache Adobe or Apache Spark. So all these softwares are used for storing the information regarding to the accounting or material planning and control. Next, if you see the third one, purchasing. So data provided by purchasing for a material. So if the X company is buying around 1,000 products, okay, when you, in your company, so that's called purchasing your products. So those information you should store in the store. You should store in the software. Okay, see, there will be a lot of companies will be there. Okay, they will take your product. So there will be 1,000 companies. Okay, will be taking your product. Like if you take the soap company, so there will be a lot of customers will be buying your soaps. Example. So you should store all the data. Say X company, how much they're purchasing. Y company, how much they're purchasing. Z company, how much they're purchasing for a month. So all these data you should store, okay, in the master data. So data provided by the purchasing for a material. Example, purchasing group. So group of buyers responsible for a material, over and under delivery tolerance, and the order unit. So all this okay, you should what are the order they have, what are the if example XY company, how much they are given orders for us. So for each month, how much we should supply for them. So all these things, okay, we should store in the material master data. Then engineering. So engineering, you know, that is CAD data. Okay, so engineering and design data of on a material. So if you take CAD data, dimensions, design specifications, everything we should store in the master data, so that whenever you want, okay, if you open in the software, immediately you can get the details. Okay, like 2 years back, so what was my demand, what was my design of my product. So immediately you can open the software, and if you type the date and time, immediately you can see the date and month. So immediately you can see the design, okay, design of the product before 2 years. So all these things you should store in this material master data. Then storage, information relating to the storage or warehousing of a material. So warehousing is nothing but, okay, whatever the excess material, okay, or the raw materials, about the raw materials, okay, or you can see the unit of issue. If anything issue is there in that product, everything will store in that warehouse. Okay, so example, you can see unit of issue, that is storage condition, packaging dimensions. So all the material which will be stored in that warehouse or the excess material. So we can store all those data in this software, so that whenever you want the excess, whenever you want the extra material, okay, if you open the warehouse this one warehouse software, sorry, warehouse data, immediately you can get how much raw materials are there, how much raw materials, how much kg of raw materials are there in the warehouse, so how much we should bring, so how much will be saved. So everything, okay, we can store there. Then forecasting. So for forecasting is nothing but predicting, you know. So information for predicting material requirements. So how much you want in the next month, in the next 2 months, how much raw materials required to manufacture 1,000 products. So all this we can predict, okay, or you can say by using the software. So 1,000, you type only 1,000 materials or 1,000 products, it will say how much raw materials you required, like 2,000 kg or 2 ton, 3 ton, 4 ton, whatever it may be. Okay, immediately it will tell about the raw materials. Then sales and distribution. This is the last one. So you should store the data of sales. How much it has sales for 1 month, for 2 months, for 3 months. How much product has been sold, and distribution. How much product has been distributed. So everything you should store, okay, in the material master data. So information for sales, orders, and pricing. Example: sales price, minimum order quantity, and the name of the sales department responsible for a certain material. So all these things are called as material master data. See, material master data. So if you store all
So one doubt, sir.
Tell me, Sachin.
So what you're saying, like the thing, like the purchasing and all those things, does that come under MRP 1 or MRP 2 system, sir?
That is, I think it's MRP 1.
So MRP just contains regarding just the material, sir. But I think other than it, like the purchasing, the prices and all those things, that comes under MRP 2 system, and the data of the entire, like what you see, the company comes under ERP system.
Okay, wait. So this is sales and distribution, right, Sachin? So this is about, okay, how much sales has been happened.
So that will come under ERP, no, sir?
Okay, ERP. So this is ERP. Okay. Okay, I will tell you. I'll see this information. I will tell you, Sachin. So ERP.
Like ma'am, we had like same subject in even OM, sir. So it's like OM in OM, like this thing. It's like a big triangle, sir. So MRP 1 comes under MRP 2 also, and MRP 2 and MRP 1 comes under ERP with extra things together with it. Okay,
I will look into it. Okay, I will look into this. Okay, I will see and I will tell you ERP and MRP. Okay, what is this? So mainly these are the what you can say. These are the contents. Okay, you should save. If you save all these things, okay, for a particular material, that is called as material master data for a product. If you take a product and if you save all these things, then whenever you want, you can open the software and you can see before 2 years what was the data or what was the sales was happened, what was the distribution at the particular 2 years back. Okay, what was my price before 2 years back. So everything we can save in a software, so it will be easy for us to get the data. Okay, that is one I'm telling you. Like I told you, there will be softwares to store the data, to collect the data, and to data cleaning, you'll be having some softwares. So if you go for MNCs, okay, there will be the softwares to store the data, okay, for all these things like accounting, material planning and control, purchasing, engineering, okay. Then if you go for next, storage, forecasting, then sales and distribution, for everything there will be a software will be there. So they will be storing all those data, okay, in that software, so that whenever they required, okay, about the data, how much raw materials are required for the next 2 years or next month, so everything they can analyze, then they can give the input for the manufacturing plant or for the employees. Immediately they can tell, so this much is the raw material required, so immediately they can buy and they can send for the employees. So this is about material master data. So anyone has any doubt in this?
No doubt, sir.
So by this, today digital mockup, model building and model analysis, product planning process, product structure, and material master data. So another 2 to 3 points, this is required. One is product design, product description data. Anyway, this I told you in the previous slides. So anyway, tomorrow I will do you data modeling and data models. So this is very important.
Doubt, sir.
Tell me, Sachin.
So tomorrow do we have normal theory class, sir? Because the
No.
presentation
Tomorrow I will not take. I will take on the Thursday. Thursday 1 hour.
Okay,
I will take.
fine,
And
sir.
finish off. So anyway, 2 to 3 topics are remaining. So one is status of items, then life cycle of individual items, and data types of data. That is data models. This is very important. Then product description data. If I complete these things, I think this completes your fifth module. Everything okay. So I require another 1 hour. If I take 1 hour, then I'll complete this one. Anyway, Sachin, I'll tell you about that MRP and ERP, okay? Because those things are not there in this subject. In the PLM, okay, they are not mentioned about ERP and in the MRP regarding to this master material master data. Okay, I will see and I will tell you the answer. Okay. Then any doubts regarding to today's class, you can tell me. But
No,
mainly
sir.
the fifth module indicates the virtual manufacturing system. You should understand. Okay, these are the softwares. Okay, if you go for the company, okay, if you work in a company, okay, they will tell what are the software they're using to store the data. Okay, regarding to any product. So there'll be if a company is manufacturing 10 to 20 products. So for all the 20 products, okay, they should store the data. Okay, how much raw materials are required for manufacturing one product, like that. Okay, how much if they're manufacturing 1,000 products, how much raw materials are required for 1 month. So everything they should analyze, and they should they should send according to the needs of the manufacture of the products. So everything, okay, we can analyze, we can store the data, okay, in this MMD. So MMD indicates material master data, or it is called as master data. If you go for the company, they will tell master data. I will store the master data indicates they will store all the material for a particular product. They'll be storing all the data like sales, distribution, and the information regarding to the materials used. Okay, how much raw materials are required, and what is the machines are required. Okay, and what is the cost. Okay, and what is the accounting, what is the price we are selling the products. Okay, then they'll store the raw material regarding to the warehouse. In warehouse, they will store all the raw materials. So how much is required there. Then about forecasting for future. Okay, if I'm selling 1,000 or 2,000 products next month, so what should be the raw materials is required. Okay, so everything they will try to analyze, and they will store every data, so that it will be easy for manufacture. In the manufacturing department, it will be easy. So they will tell the information. So we want to manufacture 1,000 products. So immediately they will open this material master data software. They will get the information, and they will send those information for the for the managers. Okay, for the HR manager, for the finance manager, so that they will buy the required raw materials. Okay, financial manager. So this completes the MMD. Okay, it is material master data. Okay, So if you do not have any doubts, okay, you can ask me doubts. If you do not have any doubts, I will take the attendance and I will leave the class. So another one class, I can finish this module, 5th module. And later on, I will send the slides for you. All the slides, okay, I will send after this class. So I've taken the attendance, and I will give you the important question in the Thursday. Okay, Thursday I will post the all the 5 modules. What is that? You can say the question bank. Okay, question bank I'll be posting in the Google Classroom. Okay, students.
Okay, sir.
So everything I'll be posting on Thursday evening. Thursday, I think I'll finish the syllabus. I will clarify all the doubts, and I will be posting the question bank in the classroom, all the 5 modules, so that you can look into that, and I will tell you the important questions. Okay, for your SWE. So I can end the class, students.
Yes, sir. Thank
Yes,
you, sir.
Okay, thank you, thank you. You can leave the class. Thank you.
Oh,
ಹೇಳಮ್ಮ
ದೇವರ್
ಅರ್ಚನಾ, ಹೇಳಮ್ಮ ಅರ್ಚನಾ.
ನಾನು ಡಿಸೈನ್ ಕಲಿಸ್ತಾ ಅಂದ ಸರ್ ಅವನು ಸುಶೀಲ್
ಅದೇ